Okay, so let's see here. So we're going to give you guys a few more derivative rules. It's on Breeze. There you go. Thank you. So again, right now we are very limited with the derivatives that we are able to take, right? Again, I'll rewrite them here on the paper. Right now, if we want to take the derivative of a number, we know that's equal to 0. And right now we know if we want to take the derivative of an x raised to an integer, okay, x raised to an integer, and that's going to be just n times x to the n minus 1. Okay. Those are only two derivatives that we know how to do, all right? And even with just those two derivatives, right, things got a little complicated when it came to the homework and the warm-up there, mostly because we had to be able to rewrite things into a format that matches one of those two rules, basically. Okay? Well, we also have, you can take the derivative of trig functions. Okay? I'm not going to show you how to do that today as far as like the proof for it. Okay? You can just take my word for it. Maybe your calculus teacher will show you. Okay, but it's kind of, again, beyond the scope of what I wanted to cover here, so we'll just kind of do it. So, for example, the derivative of sine of x, the derivative of sine of x is the cosine of x. Okay? The derivative of the sine of x is cosine of x, which means that at any x value on the sine function, you can find the slope or the rate of change of the sine function by just finding the equivalent value of the cosine. Okay? At that same point. All right. The derivative of cosine, not sine. It's negative sine of x. Okay. So, for example, let's say we want to evaluate the following. Okay, just for some examples here. Okay, so let's say our function is, let's say we got like, I don't know, f of x equals 2 sine of x. So we've got a coefficient, right, 2, but we've seen in our previous rules here that with that coefficient, we don't have to worry about that, right? 2 times a function will be just 2 times the derivative of that function. Okay? So function 2 sine of x will become what? What's the derivative of that going to be? 2 what? Cosine x. Yeah, exactly right. 2 cos x. Okay? Sine of x, the derivative of that is cosine of x. 2, the coefficient there, is just going to come along for the ride. Okay, so it's the coefficient. Okay, so let's worry about it. All right. Let's try another one here. How about 4x to the fourth. Let's see here. Minus the cosine of x. Oh, I guess I want to assign like the derivative, so. We're not really evaluating the following here. We're finding the derivative. we're finding the derivative. Find the derivative of the following. That's what we're really doing here. Finding the derivative. Okay, I don't know why I said evaluate there. Well, I know why I said evaluate there. Okay. All right, ideas here? Someone think they got it? 4x to the fourth minus cosine x. So we see some subtraction there. So those are, we can kind of treat them as two separate entities, right? We got the 4x to the fourth. We want to take the derivative of that. We want to take the derivative of cosine, and we want to subtract that difference there. Okay? So what's the derivative of 4x to the fourth going to be? What's the derivative of 4x to the fourth going to be? Let's go to... Oh, Devin, what do you say there, Devin? What's the derivative of 4x to the fourth going to be?
4x to the third.
Close. The 4 has to come out front, remember, and multiply with the 4, so what's going to be? 16x to the third. Very good. You can lower the power by 1. Good. Okay. And then, Devin, what's the derivative of cosine? Negative sign. So we're going to do minus, though, a negative sign x. So yeah, if you want, and I would, you know, right? Why not? We can make it then plus the sign of x there. Okay, and so there's the derivative. Okay, yeah, that's right. Okay. Let's do one more here. Let's do one more here. Let's see. How about okay. 1 over the square root of x plus 3 sine x. 1 over the square root of x plus 3 sine of x. Okay. And again, remember, we only have these 4 derivative rules really to help us evaluate these, right? So let's see. It looks like in number 3, right? If you look at number 3 here, we don't have a constant, right? There's no like just straight up number here. Like if there's a plus 3 at the end or something like that, then we could know that that's the root of that 3 would be a 0. But in this case, it's 3 times sine x. That's a coefficient, so we're going to have to use that coefficient rule that we have there. We do have an x being raised to a power here, but it looks like we maybe need to rewrite this. How should we maybe rewrite this 1 over the square root of x to a format that we can then use to take the derivative? How should we rewrite that 1 over the square root of x first? What should we rewrite it as? Okay, we need that 1 over the square root of x to be just x to a power. So 1 over the square root of x is the same thing as x to what power? Yep, Cassie? Yeah, negative 1/2. Yeah, in this case, right. If we want to do it all at once there, yeah. 1 over x to the positive 1/2, or then just x to the negative 1/2, right. And then plus 3 sine x. And again, rewriting that, that's not taking the derivative, right? This is still the function. This thing is equivalent to this thing. So now, we have it in a format where we can take the derivative. So we'll take the derivative there, f prime of x. And so the derivative of x to the negative 1/2, all right, Alyssa, what's that going to be? Sorry, what's the derivative of x to the negative 1/2 going to be there? Yeah, very good. Right, because then we take the derivative of that. So it'll be 3 cosine x. Yes. Exactly. The derivative of sine is cosine. So the derivative of 3 sine x will be 3 cosine x. And so there's our derivative. There's our derivative. If you want to, you can move the x down to the denominator. It's up to you. If you wanted to, you can make this, negative 1 over 2x to the 3/2 like that. Like so. Okay. Kind of up to you. But yep, that's it. Okay. Questions on 1, 2, or 3 there? Questions on 1, 2, or 3? All right, I'm going to show you one other function that we've seen before here. One other function, and that is the derivative. I guess I'll put it up here with all the other ones. All right. That's the derivative of the natural exponential function, e to the x. Okay. The derivative of e to the x is e to the x. Okay. Again, if you take calculus, that's something, you know, that's an easiest derivative that you have to learn in calculus. The derivative of e to the x is e to the x. It is its own derivative. Okay? It is its own derivative. Okay. So that's the other kind of like function that we're going to be learning about their derivative. Okay, we're still going to look at the product rule and the quotient rule, but that's the only function we're going to look at today. Only other function we'll look at. So, okay. Let's see here. So let's just do one more example here then. So with that being said, now let's find the derivative of one more function here. And again, it's not going to be too out of this world here. So again, if f of x equals 3 cosine x minus e to the x. So f of x equals 3 cosine x minus e to the x. Okay. What would that derivative be? It's already in a form. No, we can take that derivative there. So what would that derivative be? What do we say? What would the derivative of this be? Let's go to someone who's here. How about Nick W? What do you say there, Nick? What's the derivative of 3 cosine x going to be? Negative 3 sine x. Yeah, because derivative of cosine is negative sine, so it'll be negative 3 sine x. And then minus, and what's the derivative of e to the x? E to the x again. Yeah, that's it. There it is. Good job. Okay. Good. Let's do one more question here. This is a bit of a different question, so I'm going to change the directions up here. So the directions now, I want us to determine the points on the curve, or function if you want to think about it, where the curve has a horizontal slope. Okay, so we want to determine the points on the curve where the curve has a horizontal slope. Okay, so I'm going to give you a curve here, right? I'm going to give you a curve. So let's say our curve here is f of x, the function f of x equal to 3x plus 3 sine of x. And we're going to only stick, because we're talking about trig functions and stuff like that, we'll stick for 0 less than or equal to x less than 2 pi. Okay, so we'll just keep it like, between 0 and 2 pi. So determine the points on the curve where the curve has a horizontal slope, or determine the points on the function where the function has a horizontal slope. Okay. So again, what do we use to determine the slope of a function? The what? What helps us find the slope of a function? Or what do we do to find the slope of a function? What helps us find the slope? How do we find the slope of a function? What do we do? What's the calculus thing that we do? slope of a function. Well, remember, right, when we talked about constant functions, right, so back in the beginning, right, or the first thing we did yesterday, we talked about the constant functions, right, so if a function is equal to like 3 or 4, right, we said when we took the derivative of that constant, 3, 4, 10, whatever it is, we get 0. And the reason for that is because the slope of the constant function, right, is always a slope of 0. If it's a horizontal line, the slope is always going to be 0 there, right? And so how we get the slope of the constant function? We took the derivative, right? Okay. When we had x squared, we were like trying to figure out the slope of x squared there. We looked at the derivative to kind of help us figure out the slopes there at different points. We also looked at the function itself too. So we want to find the slope of this thing, this function here. If we want to find the slope of this function, what should we do to this function? What should we do? What's the calculus thing that we need to do? Any ideas? Any ideas? I'm just going to sit here for another hour or two. See who gives in first. No ideas? I completely lost everyone. Don't want to answer. Start the clock. All right, well, maybe we're not ready for that question yet. We'll move on. Try something different. What's that? Oh my gosh! I don't know how long that took, but yes! We want to take the derivative to analyze the slope. All right. I know a lot of you guys are thinking it too, but you just didn't want to say it. Trying to see how long I'm not going to sweat up here. All right. Anyway, what's the derivative of this thing? Now that we do it, what is the derivative of this thing? Oh, silence again. What's the derivative of 3x? 3. What's the derivative of 3 sine x? 3 cosine x. Okay. So now we have the derivative. But we're not just interested in the slope at any point. We want to know the points where the curve has a horizontal slope. So if we have a horizontal slope, what is the value of that slope going to be? What's the numeric value of that slope going to be if we have a horizontal slope? 0. 0. Okay? So we want to know where our slope is 0. So we set our derivative equal to 0. Set our derivative equal to 0. The derivative describes the slope of the function. We want to know when our function's slope is 0. So we'll do that. 3 plus 3 cosine x. Now we have an equation. All right? So let's solve here. Negative 3 plus 3 cosine x. Or sorry, negative 3 equals 3 cosine x. So that means negative 1 equals the cosine of x. So that means x equals, when is the cosine of x equal to negative 1? For what radian measure, right? We're going between 0 and 2 pi. So for what radian measure is the cosine of that going to be negative 1? I know, we're going back to last year, guys. This is a long time ago. Last year, okay? So when is the cosine of x equal to negative 1? At pi! Okay? Pi is our answer there. All right, and sure enough, if we look at this on our graphing calculators here, so I'll do that for us. 3 plus 3 cosine x. So I'm going to graph the original, 3 sine x. 3x plus 3 sine x. going off the rails here. So we're graphing the function here, the original function, because we wanted to know the points on the curve, the original function there, where the curve has a horizontal slope. So I'm going to graph the original function and try and find this point where x is pi and see if we believe that, yeah, it looks like it's going to have a horizontal slope there, right? So let's graph this thing. Actually, I should check to make sure my mode is, oh, it is in radians. That's a good thing. Okay. Okay, so let's see here. At x equals pi, so I do, let me adjust my window just a tad here. I'll go to like 13. That should maybe fit it better. Okay, well, it certainly looks like our curve does kind of flatten out there. Maybe, if not, you know, exactly flatten out, maybe for an instant it's going to flatten out. Okay, so if I do second trace, and I'll go to value, I'll type in the x value of pi, and sure enough, it locates that point where it looks like it maybe flattens out just for an instant and then starts to increase once again. So the slope there, it looks like, is going to be 0. So there we go. There we go. All right, we do have a slope of 0 at that point there. Okay. Let me ask one more question here. All right, and one more here, and then we'll look at the product rule. All right. So for this one, I am going to have us just evaluate. Okay. We're going to evaluate this limit here. And let me see, which limit do I want to do? Okay. Let me think about this. I'll just do it this way, yeah. Again, just kind of throwing some, well, yeah, I don't want to say too much. So now for this one, we just want to evaluate this limit. The limit is h comes to 0 of sine of x plus h minus sine of x over h. We can try direct substitution, right? Plug it in 0 for the h's, but we're going to get sine x minus sine x will be 0 in the numerator over 0 in the denominator, so we get 0, 0 indeterminate form. You try multiplying by like the conjugate here, and that won't really help. Okay. But does this limit look familiar? Does this limit look familiar to us? Is it something that we've seen before? Right? It's this. So what is this limit really asking us to do? What is this limit asking us to do here? When you see this, what's it really asking us to do? Remember, I called this thing, right? This is the limit definition of the derivative. Okay. The derivative of what, though? In this, what are we taking the derivative of here? In the generic kind of sense. It's the function f. So what's our function here that we're taking the derivative of? In this one. The way this limit is set up, what's the function we're taking the derivative of here? It is, yeah. Sine of x, exactly right. This is literally saying, what is the derivative of sine of x? Okay. So, what is that, Spencer? What's the derivative of sine? Yeah, cosine x. That's it. Don't have to do any work there. No work necessary. All we need to realize is that that thing, that limit, is asking us to take the derivative of sine of x. What's the derivative of sine of x? Cosine x. Okay. So, very easy. No need to like run through all the craziness with the value and the limit and stuff like that. All right. So let's move into then the product rule, and we'll see if we get to the quotient rule too. But we'll just work on the product rule for right now. Okay. So the product rule. Here we go. Well, actually, before we go to the product rule, let's talk about. Yeah, I have an idea. Okay, sorry. So let's first consider f of x equals x squared times x to the fourth. So right now, we cannot take the derivative of this thing the way it's currently written. We can't do it. Okay? We don't have a kind of rule for when we have two things being multiplied together like that. Okay? If they were being added, so if it was x squared plus x to the fourth, no problem. You take the derivative. It would be 2x plus 4x to the third. Okay? But because it's being multiplied here, we don't have a rule for that. So we need to, right now, rewrite it. Okay, so rewrite it. So we can just rewrite the function here. X squared times x to the fourth is equivalent to saying x to the what? What's that equivalent to? X to the what power? 6. X to the 6th. Okay? So since it's x to the 6th, now we can take the derivative, right? So then f prime of x equals x to the 6th. Okay. Now let's go back and we'll reconsider the same thing. Okay, so we'll try the same thing. And now let's try it the way we maybe want to try it. We want it to work. Like we want to be able to take the derivative of the individual pieces and multiply together. Okay, so take the derivative of x squared and x to the fourth individually and multiply the results. Okay, so in other words, if we have x squared and we want to take the derivative of x squared, well, we know that's just going to be 2x, right? And if we take the derivative of x to the fourth, that will be what? Anybody? 4x to the third. Good. If we multiply those two answers together, 2x times 4x to the third, we're going to end up with 8x to the fourth. All right. Is 8x to the fourth the same thing as x to the sixth? Right, no, it's not. So in other words, right, this is just to kind of give you an example to show you that when we have two things being multiplied together, two kind of functions with x in it, so x squared times x to the fourth here, we have two functions being multiplied together like this, okay? You cannot take the derivative of the individual pieces and then multiply it back together to get their answer, right? 2x, if we take the derivatives of the individual pieces and multiply them together, it's not equivalent to when we simplified it, x to the sixth, and then, oh goodness, I wrote that derivative way out there. I apologize. It should be 6x to the fifth there. I did not actually take the derivative there, so sorry about that. Okay. But again, still, they're not the same thing, and that's really what my point was there. The derivative here of x to the sixth is 6x to the fifth. That is not the same thing as 8x to the fourth. Okay, so we have to be careful. You need to try and multiply these two things together before you then take the derivative, right? We can't take the individual derivatives like this and then multiply them together. They're not the same thing. Okay, this is the right answer. This is not. Okay, how you take the derivative there. So, in other words, is it true that the derivative with respect to x of f of x times g of x equals and the answer right? No. Okay. You have two things being multiplied together. Okay. In general, it's not true that then that's equal to the derivative of those two things again. But there is a rule to help us take the derivative of a product, and that is the product rule. And there's kind of a proof for it. I'm not going to show it to you here. Again, I think that's, more than we maybe need to worry about. Maybe not. I don't know. But the product rule. So there is a rule here, and here it is. So if we do want to take the derivative of two things multiplied together, okay, like x squared times x to the fourth. Now, granted, you could just multiply them together here, right? These two you can easily do, just multiply them together, get x to the sixth, and then take the derivative, no problem. But we have two things we can't multiply together. All right, the derivative is equal to f of x times g prime of x plus g of x times f prime of x. First times the derivative of the second, f times the derivative of g, plus the second, g, times the derivative of the first, f. That is the product rule there. Okay, that's the kind of shortcut you can use to help take the derivative of a product when you can't multiply it out. Okay. So, let's take an example of this. So let's actually go back to our original problem here, this x squared times x to the fourth. Let's do this using that product rule here. So let's say we want to take the derivative of x squared times x to the fourth. Okay, just like we did up here, we know the answer. It's got to be 6x to the fifth in the end. But let's do it with these two things being separate like that. Okay. So what does this mean? Well, that x squared, that's like our f of x. And that x to the fourth, that's like our g of x, right? So according to the product rule here, the first thing I should have is f of x, which was x squared. So that's easy. Okay, it's going to be x squared, and then times the derivative of g. So then what should be the next thing that I write? If this is g, x to the fourth is g, and I want to multiply by the derivative of g, what should I multiply this by then? Anybody? 4x cubed. That's right. Plus, now g of x. Well, that's just x to the fourth times f prime of x, which is the derivative of f. So times what then? 2x to the 1, or just 2x if you want. Alright, so let's simplify this here. X squared times x cubed, that's 4x to the fifth. X to the fourth times 2x, 2x to the fifth. 4x to the fifth plus 2x to the fifth, 6x to the fifth, which is the exact same thing we got up there. Okay? Mr. Whitmire, it's more work this way to use the product rule than it is to just multiply it out. Yeah, you're right. If you can multiply it out first and then take the derivative, that's fine. Sometimes, though, there are situations where you can't multiply it out first. Okay? So like this one, you could totally just do x squared times x to the fourth, boom, be done with it. But what about something like What about something like this? You can't multiply x squared with sine of x as to make it one term, right? We can't just multiply those two things together. They're separate, right? X squared and x to the fourth, those were able to be multiplied together. But x squared and sine x, they're different. We can't put them together. It's still a product, though. It's a product of two things. It's a product of x squared and sine of x. And so we have to use the product rule here. Have to, okay? So this is like, again, our first one, f. This is like our second one, g there. And so then f prime of x will be the first one, f. So it's going to be the x squared times then g prime, the derivative of sine. We know that is cosine. Plus, and then let's see here, g of x, so now just sine of x, times f prime, the derivative of x squared, which is times 2x. And so this thing is then x squared, the derivative is x squared cosine x plus 2x sine x. I'll go ahead and put the 2x out front there, like that. That's the derivative. Okay? You have no choice there but to use the product rule. No choice there but to use the product rule. Questions on any of that so far? All good so far? All right, let me do one more here for you guys, and then I'll have you guys yeah. Okay. So let's see here. Let's again, we'll just say, I don't know, find f prime of x. Find the derivative of f here, given f of x. I don't know, let's say f of x is x squared times 3 plus 4x cubed. Do we need to use the product rule here? Do we need to use the product rule here? No. Okay. To avoid using the product rule here, what can we do to this problem? Before we take the derivative, distribute the x squared. Exactly right. So what we could do here to avoid having the product rule, we could distribute the x squared to each term here, and then take the derivative because it would be just like a normal polynomial. Okay. But again, let's use the product rule here. Let's use the product rule, and then we'll check it with that easier way. Okay. Let's use the product rule here. So our two things that we're multiplying together are x squared, and then the second thing is that 3 plus 4x to the third, right? Those two things being multiplied together. So we'll say that's like our f, that's like our g there. Okay. So again, going back to our product rule up here, it's the first times the derivative of the second. So it's the first function, x squared, times the derivative of 3 plus 4x cubed. Well, what's the derivative of 3? 0. What's the derivative of 4x cubed? 12x squared. So it's going to be 0 plus 12x squared, which is really just then 12x squared. Okay, so again, it's the first function, x squared, times the derivative of the second function there. So the derivative of 3 plus 4x cubed is just 12x squared. And we have to add to that, so plus g of x, the second function here. So you're going to add to that this one, times the derivative of f. What's the derivative of x squared? 2x. That's right. Okay. So there's the derivative. We could leave it like that, but let's simplify it just because. So x squared times 12x squared is 12x to the fourth. Let's see here, 2x, we'll distribute that to those two terms there, so it's going to become 6x plus 8x to the fourth. Yep, and so then the 12 and the 8 combine together to make 20x to the fourth plus 6x. What if we distributed? Well, if we do that, that makes this thing 3x squared plus 4x to the fifth. And if we take the derivative, sure enough, that 2 will multiply with a 3 to make 6x. That 5 will multiply down to the 4 to make a 20x, and then you subtract the power by 1, so 20x to the fourth. So there it is. So we would get the same thing there if you distributed and then took the derivative from the distribution. That's the idea. So now we have some new tools we've added to our arsenal. We've expanded the number of derivatives that we can now take, right? We had started yesterday just being able to take the derivative of a number and the derivative of x written to a power, and then of course any sum or difference of those things, a combination of sums or differences of those things, right? So anytime you like add or subtract these things, we could then take the derivatives too. Today we also talked then about sine, its derivative is cosine, and cosine's derivative is negative sine, and then the derivative of e to the x is e to the x, okay, which is an easy one to remember, all right? But they were still very limited, right? Very limited, very limited. Then we talked about kind of expanding things just a little bit more by the product rule. When you have two functions being multiplied together, that's equal to then the first function times the derivative of the second plus the second function times the derivative of the first function. Okay, and that simplifies. That gives you the product rule. Okay, so right now we're going to just pause right there. Okay, and we'll see how we go with that. So I'm going to give you guys some practice. I have a worksheet. Okay, to try here. So just get more comfortable with it.